Toshiba device and storage. Cmos logic ICs. E-learning. 4. How to read datasheets. Reading datasheets. This section describes how to read datasheets using a datasheet for an IC of the 74VHC series. Reading datasheets. Absolute maximum ratings and operating ranges. Absolute maximum ratings. Exposure to stress exceeding absolute maximum ratings might cause permanent destruction or reliability degradation of an IC. Operating ranges. This table shows the conditions under which the functional operation of an IC is guaranteed. Reading datasheets. DC electrical characteristics. This section describes major DC characteristics shown below. Reading datasheets. Input voltages, VIH and VIL. DC characteristic 1. Input voltages, VIH and VIL. The voltage at which an input signal is determined to be high or low is called threshold voltage. The VIH and VIL of Cmos logic ICs are designed to be 1/2 VCC. Reading datasheets. Output currents, IOH and IOL. DC characteristic 2. Output currents, IOH and IOL. The drive capability of the output buffer and the guaranteed output current are important when connecting a Cmos logic IC with an LSI chip. Cmos logic ICs are designed to provide almost the same drive capability at both IOH and IOL. Reading datasheets. Input current, IN. DC characteristic 3. Input current, IN. Since the Cmos logic IC is a voltage-driven IC, almost no input current, IN, is required. The input current, IN, is leakage only and as low as several nanoamperes. Reading datasheets. Quiescent supply current, ICC. DC characteristic 4. Quiescent supply current, ICC. Cmos devices consume much lower current than other types of device when they are inactive. The quiescent supply current, ICC, of the Cmos device is leakage only and as low as several nanoamperes. Reading datasheets. AC electrical characteristics. AC characteristics of the 74VHC04FT. AC characteristics include propagation delay time, input capacitance, power dissipation capacitance, and so on. Reading datasheets. Propagation delay times, TPLH and TPHL. AC characteristic 5. Propagation delay times, TPLH and TPHL. Ideally, an output signal should change immediately in response to changes in an input signal, but there actually is a delay. The time required for an output to change in response to an input change is called the propagation delay time. Example. 74VHC04. The reference of the propagation delay time due to the power supply voltage and the test circuit of the propagation delay time are shown. Reading datasheets. Power dissipation capacitance, CPD. AC characteristic 6. Power dissipation capacitance, CPD. CPD is defined as the value of the internal equivalent capacitance which is calculated from the operating current consumption without load. As the operating frequency increases, the supply current of a Cmos logic IC increases. Example. Input frequency, Fin, vs supply current, ICC, slope of the 74VHC04. The reference of the input frequency Fin vs supply current ICC of 74VHC04, and the test circuit of the power dissipation capacitance are shown. The operating supply current is determined by the charging and discharging current of internal equivalent capacitance and output capacitance. Therefore, the operating supply current is proportional to the input frequency, Fin. Reading datasheets. Input tolerant function. What is the input tolerant function? A Cmos logic IC with an input tolerant function allows a voltage of up to the maximum operating voltage to be applied to an input while the power supply is active or at 0 volts. The input tolerant function allows level shifting from a higher voltage to a lower voltage. Examples of level shifting. Down translation from 5 volts to 3 volts. Use the 7.4 VHC or 7.4 LCX series. Down translation from 3 volts to 1.2 volts. Use the 7.4 VCX series. The following shows an equivalent circuit for a typical Cmos logic IC. The diodes on the input side are inserted for the purpose of VSD protection, whereas those on the output side are parasitic diodes. The diode between the input and the power supply might turn on if a voltage higher than VCC is applied or voltage is applied when the IC is off. In this case, the IC might be destroyed by the resulting large current. Device destruction can be prevented by using an IC with an input tolerant function, i.e., an IC without a diode between the input and power supply. It is easy to distinguish whether an IC has an input tolerant function. Let's look at the datasheets for ICs of the TC74HC and 74VHC series. See the input voltage shown in the operating ranges table. The datasheet of the TC74HC series shows Vn equals 0 to VCC. This means that the input pin is tolerant of only up to VCC. Therefore, the TC74HC series does not have an input tolerant function. In contrast, the datasheet of the 74VHC series shows Vn equals 0 to 5.5 volts, meaning that up to 5.5 volts can be applied to the input pin regardless of VCC. Therefore, the 74VHC series has an input tolerant function. Reading datasheets. Output tolerant function. What is the output tolerant function? The output circuitry of Cmos logic ICs has a totem pole configuration consisting of a pair of P-channel and N-channel MOSFETs as shown below. Typically, Cmos logic ICs have a parasitic diode between an output and power supply. The parasitic diode turns on when voltage is applied to an IC when it is off, or to an IC with the 3-state output, such as the 7.4 LCAX245, when it is on. The IC might be destroyed by the resulting large current. Even when a voltage higher than the supply voltage, VCC, is applied to the output, current does not flow into an IC with an output configuration that does not have this parasitic diode. Such an IC has an output tolerant function. It is easy to distinguish whether an IC has an output tolerant function. Let's look at the data sheets for ICs of the 7.4 VHC and 7.4 LCX series. See the bus I/O voltage shown in the operating ranges table. The datasheet of the 7.4 VHC245 shows VIO equals 0 to VCC. This means that the output pin is tolerant of only up to VCC. Therefore, the 7.4 VHC245 does not have an output tolerant function. In contrast, the datasheet of the 7.4 LCX245 shows Vn equals 0 to 5.5 volts, meaning that up to 5.5 volts can be applied to the bus I/O pin regardless of VCC. Therefore, the 7.4 LCX245 has an output tolerant function. Reading datasheets. Power down protection. What is power down protection? To reduce power consumption, a system with 2 voltage domains, VCC1 and VCC2, might provide partial power down mode in which the subsystem operating from VCC1 is shut down. Suppose, for example, that the 7.4 VHC series is used in the VCC1 domain. The 7.4 VHC series has an unintended parasitic diode between the output and power supply. Therefore, when VCC2 is greater than VCC1, this parasitic diode turns on. In this case, the IC might be destroyed by the resulting large current. Device destruction can be prevented by using an IC with neither an input nor output parasitic diode. E.g., 7.4 VHCT, 7.4 LCX, and 7.4 VCX series. These series provide power down protection. It is easy to distinguish whether an IC has a power down protection function. Let's look at the data sheets for ICs of the 7.4 VHC and 7.4 LCX series. See the DC characteristics table. Power off leakage current, IOF, is specified in the data sheet for the 7.4 LCX245, which indicates that leakage current does not flow even when power supply is off. Therefore, the 7.4 LCX245 has a power down protection function. In contrast, IOF is not specified for the 7.4 VHC245. Therefore, the 7.4 VHC245 does not have a power down protection function.